Hello guys, welcome back to the 30th guy. So today is Neetcode 7 and the question is products of array except itself. So we have given an array, we need to return an array containing the product of all the elements except current element. So if we are at 0th index, then we will return the product of all the elements except 0. Like 6 into 4 is 24 into 2 is 48. It is at this position. And for the first index, it will be 6 into 4 into 1, which is 24. And for fourth, it will be 6 into 2 into 1, which is 12. And for this, it will be 4 into 2 into 1, which is 8. So this is pretty straightforward question, and it's an easy one. I'm not sure why it's in medium category. So one reason is because of they have given it like this: could you solve it in on or big of n time without using the division operation? So the first thing that comes to our mind is to product all the elements, like 6 into 4 into 2 into 1, it will become 48. Then when we go at every index, we will divide its current value, like 48 divided by 1, it will be 48. 48 divided by 2, it will be 24. 48 divided by 4, it will be 12. 48 divided by 6, it will be 8. So that's how we can get it, but they have already mentioned that we cannot do it like this. And also there is one more reason: if we product this, if enums contain an element which is 0, then the product will become 0. Okay, and then we cannot get our required answer from that. Like if the product is 0, how can we get this 0 and minus 6, right? So for this we have to take first I will try to explain how will we do this, and then we will solve this. Okay, we need to take two arrays. One will contain left sum and one will contain right sum. So for this index, I will multiply the left and right, and it will become 48. For example, I will tell you, wait, we have this nums array. If we have this another array, and this is our answer. Okay, let's say this is our answer. This is our left, right, left. Okay, so as we go from this position, we will first create this left sum array. Let's call it left sum. Okay, and we call it right sum. So at this position, what is the value of left sum? It is 1. It is 1, obviously. We will initialize it with 1. Then at this position, what is the value of left sum? It is 1. Okay, so this is 1. At this position, what is the product of these elements, like 1, 2? It is 2. At this position, what is the value of left elements? 4 into 2 into 1, it is 8. So this is the left sum array, and now let's create our right sum array. At this position, what is the product of elements to its right? There is no element, so we will write 1. At this position, what is the value of all the elements to its right? The product of them, it is 6. At this position, it will be 6 will be multiplied by this 4. That's how we will get this value 24. Then at first index, what is the value of right sum? 6 into 4 into 2. 24 into 2 is 48. So we have created these two arrays. Now we just need to multiply them. 1 into 48, 48. So at this position, what are we doing? We are saying that if we are, let's say, at this position 2, then we are saying what is the left sum, what is the right sum? 24. And what is the left sum? 1. So we will multiply both of them except this element. Okay, so that's how we will get this value. So 6 into 4 is 24. 24 into 1, 24. And now 6 into 2, 12. 8 into 1, 8. That's how we are going to solve this. Let's quickly check how will we write the code. Let's take int left sum is equal to new int n int right sum new int and in let's also create an answer array. Answer new int n. I haven't specified what is n. Int n is equal to nums dot length. Now let's first create left sum for int I is equal to 0, I is less than n I plus plus. So we know the first index will already be 1 because the left sum first element will always be 1 because this is the first index, right? There is no element to its left, so we will write 1 for it. We cannot write 0 because it will make our whole array 0. Left sum is 1, and now we will say left sum of 0 is 1, sorry. Left sum of I starting from 1, so left sum of I is equal to left sum of I minus 1 multiply by nums of I minus 1. So at every element, at every index, we are saying that multiply this element left sum I minus 1 into nums of I minus 1. If let's say we are here, then we are multiplying this one into this one. So that's how we will get this one. And now we have created it. Now let's just create a right sum. So it will start from right. So we will say right sum of n minus 1 is equal to 1. So similarly, if we are writing the right sum for this index 6 for 6 value, then we are saying there is no element to its right, so we will write 1 for it. Let's like this. And for in I is equal to n minus 1, n minus 2, I is less than, I is greater than equal to 0, I minus minus. So we are starting from n minus 2 because this is n minus 1 and the sixth position, this is n minus 1, and we are starting from this index because we have already wrote for this index. Okay, so now we will say right sum of I is equal to right sum of I plus 1 multiply by nums of I plus 1. This is similar to the above left sum. So now we will traverse our whole left sum and right sum in int I is equal to 0. I is less than n, I plus plus. I'll say answer of I is equal to left sum of I multiply by right sum of I. So we will just multiply these value 1 into 48, 48, 1 into 24, 24. So at the end we will be left with our answer array, which is will be our answer. Okay, so this is working, but you know what are we doing here? We are taking n space for left sum, n space for right sum. Although we are solving it in big O of n time complexity, but we are running loop 3 times, so it will be big O of 3n. But it is also set. It will be also similar to this big O n because 3n is also big O of n. But we can optimize it. How can we optimize it? Let's say if we don't take this left sum and right sum, okay, and we just use this answer array in our let's say in our answer array we are storing the left sum, okay, so we will reuse this answer array for everything, okay. Then instead of right sum we will just use int right sum, an integer value. I will tell you how we will do this. Then we will start from the end n minus 1, n is greater than equal to 0, and then we'll go backwards I minus 1s. Now how will we reuse this answer array? So let's say instead of this left sum I have this answer array. Now this is not left sum, this is answer. answer. Okay, my writing is very bad because I'm using touchpad. So there is no right sum, there is no this array. So we are having this now 1128. Okay, so if my right sum is equal to 1, I am starting from here. I am saying that this is the value of all the elements to its left, right? And right sum is the value of all the elements to its right. Now currently there is no element, so I wrote 1 to it. Okay, so at this index I am saying multiply these values, or not these values but these values, because we are taking uh, product of all the elements to its left. So currently if we are this index, we will say 4 into 2 into 1, which is 8, multiply by this right sum, which is 1. So we will go at every index and we will say left sum of I multiply by right sum. So 8 into 1 will be 8. That's why we are having 1, 1, 2, and 8. Right sum was 1. Okay, right sum was 1. Now if we traverse it from backward, we will say multiply this value is already left sum, into right sum, it is 8. Okay, so we will keep it as it is 8. This is done. This is our answer array containing left into right with 8, and this is our also in our answer, this is 8. Okay, now we will update our right sum. As we go here, we will go here, before going here we will say what is the right sum now. Before that it was 1. Now what is the right sum? At here, what is the right sum? We will say rightmost right sum into nums of I, which is 6. So it will become 6. Okay, this is all these things we are doing in one iteration. How? I will tell you. Like answer of I is equal to left answer of I multiply by right sum. Right sum was 1 at the last index. Then we will update this right sum here. Right sum is equal to multiply right sum is equal to right sum multiply by nums of I. So before going to the next iteration, we will say update the right sum. How? By multiplying it with the current nums value. This is the current num value, which is 6. So we will multiply the right sum by 6. So it will become 6. Now we are here at 2. We are saying that at this index, left sum is 2 and right sum is 6. So we will multiply this and add it 12. Okay, because 2 into 6 is 12. And now we need to update the right sum. How will we do it? We will say right sum, which is 6 multiplied by this index 4 value. So it will become 24. Okay, it is not 6 anymore, it is 24 now. Now we will go here. We will say 1 into 24, 24. And we will update this. What will it be updated to? 24 into 2. It will be 48. Then we will use 48 into 1, which is 48. And we need to update the right sum, which is 48 into 1, which will remain 48. And now we are out of the iterations and we have got our answer 48, 24, 12, 8, which is our required answer. So we can optimize the solution using this simple answer array without using 3 arrays. Okay, let's try to run it and see how it's working. Okay, we're getting an error. 48, 24, 6, and 1. We are multiplying it, right? We are not updating right sum or answer I. Answer I is equal to answer I into right sum, which is 1. Okay, then right sum is equal to right sum multiplied by nums of I, which also seems correct. But is this right? Here we are doing some mistake. We are saying that answer of I is equal to answer of I minus 1 into nums of I is I minus 1. We are not taking the left sum correctly. This is correct. So I hope you got this. There was an error. I thought it was already correct. I didn't look through it. Let's try to submit it. This is left sum, okay? Yeah, it's working fine. So its time complexity is big of n because we are running two for loops of n size, and so it's 2n, and space complexity is also n. Okay, I hope you got this, and it's an easy one. You just have to use your mind and optimize it. Okay, I'll see you in next one.